Hi, this is Chuck Calio from the Systems Unit IBM ISV Enablement Team, and today I'm going to give you an overview of Docker containers. Cloud computing has three main application delivery choices. Bare metal, which you're pretty familiar with probably, means that you take an isolated environment and deliver the application installed and run on in a basic set of cloud environments where there's no virtualization or container technology applied. The second one you're probably familiar with is virtual machines, where you run applications, individual applications under the control of a virtual machine such as Power VM or VMware or Microsoft Hyper-V, and then you also run those applications under the control of an operating system. The third one is new, and that's containers, and containers comprise just the essential parts of the application, cloud service, a microservice, and its dependencies. They're much smaller, much faster to deploy, and that's the basis for Docker and Docker Hub. In this next chart, we'll do a little bit more of an overview of containers. Containers are individual applications, so think of an individual next generation cloud service application as like an app on your phone. It just does one or two or three different sets of functions. It's relatively small. You encapsulate that function in the binaries and the libraries that it needs, and you run that in a Docker engine. You run that in a runtime engine. You don't run that individual application along with a hypervisor and an operating system all in a VM. You run just cloud microservices as containers, one Docker engine, one host OS, typically Linux, on one server. Here's another chart that compares containers versus VMs. On the left, virtual machines are fairly heavyweight. You take an individual application in its entire runtime, then a complete copy of the operating system, and then you run that under the control of the hypervisor and the hardware. And as you start to have multiple virtual machines on an individual host system, each of these can be 8 gig, 4 gig in size, and fairly substantially large. Now, each application runtime includes an instance of the guest OS, and even a slightly modified application requires a brand new VM. The overhead in I/O and anything is emulated, so there is pretty substantial, or can be substantial, overhead on an application when you run it on a VM. On the right-hand side is containers. Containers are just exactly the smallest amount of an application in a runtime combination that you need, typically a cloud service that does one thing. Container resources can be shared between different containers, so if I need a container resource in app A and A prime and B, then I can share them, and I can pull pre-built containers off of registries like Docker Hub. And as you can see from this chart, containers are much smaller footprint and also much faster provisioning and deprovisioning times. Multiple containers can run under the control of one operating system, typically Linux, and the host system or a VM as an option. You can actually run containers under VMs. This next chart talks about workload profiles that are optimal for containers or where containers can add high value. Any type of brand new cloud workload, or for developers that are used to cloud microservices that have already standardized in using, developing microservices and running them containers, would be your primary target. So any new cloud application, essentially. Any new born on the cloud microservices, small microservices written in a platform as a service environment like an IBM Bluemix or a Cloud Foundry or other, that are developed for cloud containers and, for example, use Docker, Docker Hub, they're optimized for execution in containers. Third category is traditional Linux applications that you want to refactor and deliver them as cloud services, and they're also good candidates to deliver as a container. Brand new applications that you would see benefiting from the large existing ecosystem of shared containers already pre-built, so a mashup of an application of something new utilizes pre-built containers, for example, taking out a Docker Hub would also be a good candidate. Any cloud application that requires very fast startup and deprovisioning times, any cloud application that requires the smallest footprint possible, and cloud services that can take advantage of large scale-out environments are typically very good candidates for containers. Popular use cases for Docker containers include any kind of developer who's already standardized on a cloud platform as a service DevOps environment, typically use a Docker container. including to develop a new cloud microservice. The big use case is to leverage containers for agile or rapid development, rapid deployment of new cloud microservices. So any kind of agile project would tend to use Docker containers. One of the things we're noticing about containers is that it's very popular to run analytics and NoSQL big data workloads. You can also use containers for web apps. For example, WordPress would be a good example of that. Server consolidation scenarios are very good. They're very well aligned for containers. Lots of density involved. And application isolation, App A and App A Prime can be isolated from each other via application containers. Potential disadvantages of each of the approach. So the bare metal approach uses dedicated hardware, and that can quickly become inefficient and very costly, especially for workloads that have high level of variability. Bare metal hardware might not be the best choice. Bare metal hardware and software resources can be significantly underutilized and very costly if not managed properly. Second case is VMs. VMs take a long time to create. Virtual appliances can take a couple days or more to create. And the activation of a VM can be in seconds, 7, 10, 15, 20 seconds. Applications running in VMs tend to be built as very distinct software stacks. One little change and you have to rebuild the whole software stack. That can be very time consuming. Lots of VMs can have high level performance overhead and can require a lot of system resources. Some of the disadvantages of containers include containers only run on Linux or Windows, and the business case to refactor older existing monolithic software to run in a cloud microservices container may not be viable. The other thing to watch is many large traditional IT shops and runtime operations personnel don't have a good understanding of containers, and you're going to want to make sure that they understand that. And finally, one final potential issue with containers is that the delivery or the application vendor may not have created or optimized software licensing for containers yet, and you'd want to have some discussions with them about that. Okay, just a couple other words here. The IBM Docker partnership is extensive. Back in December, we announced that we have a strategic partnership with Docker, and we're working across multiple platforms, SoftLayer, x86, IBM Power, and IBM Z systems to create and deliver the next generation of enterprise-grade Docker containers where IBM does add value to that. Finally, just to let you know, ISVs or other type of partners can access Docker on Linux on Power, and I included the specific URL where you can have your ISVs go take a look at a no-charge test drive for Docker on Linux on Power. Thank you again. This is Chuck Calio from the IBM Systems Enablement team. Please contact me if you have any questions on this video. Thank you very much.